Hello, my dear friends. I welcome back you to the beginner's chemistry. In our beginner's chemistry, already we have uploaded the one lecture of our basic chemistry. Because to understand the chemistry well and good, first of all, the basics will play very crucial role and the key role. In that, in the last video, we have seen what in the last video we have seen about the how the chemistry is related to our modern life. In the modern life, how the chemistry will play very crucial role we have seen. Now, in that first, I want to recap what we have studied in our video number 1 or the lecture number 1 of our basic chemistry 1. Once a quick recap I will give you and we will move to the our video. Now, in the lecture number 1, we have studied about the how the chemistry is related to modern life. Done. Now, in that first, how the chemistry is related to the food. In the food, we have seen H2O solid, that is ice. We have seen in the ice, we will see the next H2O liquid, next glucose C6H12O6, that is in the form of the sugar, next amino acids. In that, through the chemistry we will get through the food. Next we have seen through the fertilizers. In the fertilizers, main ingredient that we will use, that is urea, and the KCl and other elements like nitrogen, potassium, clear, nitrogen and the potassium and the sulfur. These are the some compounds that we are going to use in our fertilizers. So next we have seen about the health. In the health, we have seen aspirin, next propanol in the sanitizers. Next we have seen about the classification, physical classification of the matter, that is solid that will be converted into liquid, that liquid that will be converted into gaseous. Again the gaseous, again it will be converted into liquid, and the liquid again it will be converted into solid. These are the some classifications we have seen. This is the physical classification of the matter. Next we are going to talk about the chemical classification of the matter. How the chemical classification of the matter? Chemical classification of the matter, that matter has been divided into two types. One is a pure substance and one is a mixture. One is a mixture. Again this mixture has been classified into two types. One is how it has been classified. This has been classified into two types. First of all, one is heterogeneous, one is homogeneous. Okay, one is heterogeneous and one is a homogeneous. Clear? You can see in the pure substance that again it has been classified into two types, that is elements and the compounds. What is the difference between the elements and what is the difference between the compounds? You can see here the difference between the elements and the compounds. Element, in our chemistry we are going to see the 118 elements, but here this element will have same atom. Example, if you take the sodium, the sodium will contain sodium atoms only. If you take the helium, it will contain the helium atoms only. And if you take the O2, this is a molecule, but even though it is having the same atoms, O2, but when it comes to the compound, what is the meaning of the compound? Compound, let's suppose it is having the more than two atoms. Best example, that is H2O. It is having the two atoms, right? One is oxygen atom and another is a hydrogen atom. Again these elements has been again classified into metals, metalloids, and the next is a non-metals. This is a non-metals. Clear? Now metals, metalloids, and the which one? Non-metals, that we are going to see more detailedly in the our class 11th chapter called the classification of periodic table. There we are going to explain, I will explain more clearly over there. Next, compounds, we are having the inorganic compounds and one is the organic compounds. Clear? Now here we are going to study more detailedly about the heterogeneous and the homogeneous. This will play very crucial role in the identification of the chemical reactions. First we are going to see with the hetero and the homo. What is a heterogeneous and one is a homogeneous. See what is the meaning of the hetero. Here the word hetero, we are using the word hetero. Hetero means different phase in the chemical reaction. Up to your lower classes you may study it. Heterogeneous means, example I will take you for your lower classes one. If I take the one water is a liquid. Water is a liquid. In this liquid water, if I was added one sand if I was added, clear, this is a sand, clear, two are having the different phases, right? Two are having the different phases. This is heterogeneous. Now comes to the homogeneous. What is the meaning of the homogeneous? In this homogeneous, this is a H2O. Now I was adding the sugar in it. Which I was adding? I was adding the sugar in it. Sugar. Now what will happen? Sugar, it will be dissolved in the H2O and it will form the homogeneous solution. Homogeneous solution. This is a sand. Sand will be in the solid only. Now we are having the two different phases here. Now here we are having only, this is solid. When you add it in the H2O liquid, again it has become the one homogeneous solution. But now we'll come to the chemistry through the reactions. In the reaction, how to identify the heterogeneous and how to identify the homogeneous. Now first of all, I will go with your well-known example of CaCO3. This is calcium carbonate. This is solid, right? When it was heated, it will be converted into CaO solid plus CO2 gas. Now you see, here we are having the one solid phase and as well as a gaseous phase. These two are this reaction will comes under the heterogeneous. Done. Next one. Best example, in the last class also I explained. Solid that is converting into the gas. Example, camphor. This we used to see in our temples. Why? To pray the god. The camphor we used to burn, right? That camphor also directly, that solid it is converting into the gaseous. Solid it is converting into the gaseous. This is also one example for the heterogeneous. And another example, I2 solid equilibrium with the I2 gas. Here also we are having the two different phases. Here now comes to the homogeneous. Homogeneous is a well-known example for you. First I will take it for the ammonia. N2 gas plus 3H2 gas gives rise to 2NH3 gas. Here, see, here we are having the gaseous, here also we are having the gaseous, here also we are having the gaseous. In all the three cases we are having the gaseous, right? Same phase. Now, here H2O gas plus O2 gas. Here H2O gas and the O2 gas gives rise to H2O2 gas. Clear? Now, here also at the certain temperature all are in the gaseous phase, right? All are in the gaseous phase. Done? Now, this is about the heterogeneous, this is about the homogeneous. Next, we are going to the another very important topic here, entire chemistry. First, we are going to deal with call it as a atom. Now, what we are going to deal here and what is the meaning of the atom? You can see the smallest particle of an element which may or may not have independent existence but always takes place in the chemical reaction is called as the atom. Now, here why it is having the independent existence means I will explain very clearly with one general example. How I can explain this atom with a general example? First, I will take one family. Better, I will take one family. One family I will take. In this family, we are having the one father, one mother, younger father is a younger. Let's take the father age is let's take 30 years, and let's take the mother age 25. Okay, consider. Okay, and they are having the two kids, and one kid age is, let us assume you take it as a 2 years, and better you take 3. One kid age is a 2 years. Okay, one kid age is 2, one kid age is 3. Now here what we are going to deal, smallest particle may or may not have the independent existence. You see, these kids are the atom. In this kid, smallest one, who the one which is having the age number 2 is our atom. Here this 2 age number 2 kid is our atom. Clear? Now here, without father or mother, will that kid will exist in the nature, or will it go, or he can go, or he or she can go outside of his house without any help of his father or mother? No, right? He don't have any independent existence. He has to be depend upon the father or mother. Clear? What is the definition of the atom? Here, this kid have not having any independent exist or independent existence is known as a atom. Clear? The smallest particle. This age number 2 kid is our atom. Here, this is about the atom. Next, here you can see in that our atom, if I want to describe about the atom, or if I want to show about the atom, generally we used to see atom, it is having the protons and the neutrons and the electrons revolving around it. You can see easily, you can see the picture here. Next one, clear? Next we'll move to the molecules. This is very important, and you can see here you will get somewhat confusion when I was dealing with the noble gaseous elements. Here I will make you very clearly. Listen carefully. What is the meaning of the molecules? Here this molecules is a smallest particle or smallest particles which have independent existence. Which have independent existence. Clear? Now, these molecules will have the independent existence. How this molecule will have the independent existence? Now, we are going to see how these molecules are having the independent existence. Better I will take the one father, one mother, one kids. Okay, let's take the father age is 50, mother age is around 45, and kid number 1. Kid 1 age is, let's take 20. Kid 2 is 18. Okay, now kid 2 is 18. Now what is the meaning of the molecule? Here the molecule, smallest particle which have independent existence, right? Now you can see here this kid 2 is our molecule. This kid 2 is our molecule. Then here this kid 2, without help of his father and the mother, he can go outside. Done? He can go outside, right? Same thing. That is known as a molecule. In your lower classes, you may have studied that one or two more atoms, the same atoms that combines to give the molecule. Example, hydrogen atom plus hydrogen atom will give you the H2 molecule. Clear? But here I will say you about the helium molecule. Here this helium molecule, we may don't have He2. We may don't have He2. Why we are not having the He2, that I will explain very clearly when I was started the chapter called the chemical bonding. There you will get to know why the He2 will not be existence. But here you can see this He, what? This He, we will call it as a molecule. Why? This He is having the independent existence in the nature. But hydrogen is not having the any independent existence in the nature. Clear? That's the reason this one H2 is not having, this hydrogen atom is not having any independent existence, but this He is having the independent existence. That's the reason we are calling this He as a molecule. Clear? That's the reason we are calling this He as a molecule. Clear? Now we'll move to here. Now you can see here we are having the some certain elements. These certain elements, here you can see first hydrogen and its symbol is H. Helium H. Atom has independent existence. Which one? Helium is having the independent existence. Clear? And the carbon is also having the independent existence. But I said what? Hydrogen is not having the independent existence, right? Hydrogen, and atom does not have the independent existence. But H2 will be one hydrogen atom combines to give the H2 molecule. Clear? Phosphorus is also not having the independent existence, and its molecule is P4. Now chlorine also, it is not having the independent existence, and it will be exist in the nature having the, which does not have the independent exist, and it will be exist in the nature as a Cl2 gas. Clear? That's the reason helium having the independent existence, and it will be in the independent one. And carbon is also having the independent existence, and it will be in the carbon solid. Clear? These will not have independent existence in the nature. That's the reason it will be combined. One hydrogen atom gives H2 gas. It will give P4 solid. It will give Cl2 gas. Clear? Now next we are going to move elements and its atom. Now in that molecule, here this hydrogen atom exists in the nature as a H2 molecule, right? This H2 molecule contains how many atoms? 2 hydrogen atoms. Then now helium will be exist in the nature as a helium molecule only. We are having one helium atom. Then now phosphorus will be exist in the nature as a P4. This P4 molecule contains 4 phosphorus atoms. Then now carbon will be exist in the nature as a carbon graphite. Okay, here also one carbon atom. Then next we are having the chlorine. Chlorine will be exist in the nature as a Cl2 gas. 2 chlorine atoms. Then next we'll move to the molecules or compounds. Molecules. Here first we'll go with the compounds. One or two more atoms combines to give the compounds only, right? Now you see, if I was taking the CO2 molecule. In this CO2 molecule, this is carbon dioxide, right? This CO2 molecule contains how many atoms? Total 3 atoms we are having, right? See, 1 carbon atom plus 2 oxygen atom. total number of atoms. Total number of atoms in the CO2 molecule. How many Amma? Total 3 atoms. Clear? Now comes to the SO2. In the SO2, here we are having 1 sulfur atom plus 2 oxygen atoms, right? Now total number of atoms in the molecule, that is 3. Next comes to the nitrogen. Comes to the ammonia. Ammonia, here we are having 1 nitrogen plus 3 hydrogens, right? Combines to give total number of atoms that we are having in the molecule is 4. Next comes to the, I will take one general example for you. C6H12O6. C6H12O6. Here total how many atoms we are having? You can see 6 carbon atoms plus 12 hydrogen atoms. 12 hydrogen atoms. Next 6 oxygen atoms. 6 oxygen atoms. Totally how much? 6 carbon atoms. 12. 18 plus 6. Total 24 atoms we are having in the glucose. Next I will take a well-known example for you. That is H2O. H2. Here we are having 2 hydrogen atoms plus 1 oxygen atom. Total 3 atoms. Clear? Now these are the about the atoms. Now molecule. Molecule means the one which is having the independent existence. Atom means which does not have the independent existence. Clear? Next we are going to move to the ions. What is the meaning of the ions? Here when we are moving to the ion, first of all I want to explain very clearly about the atom. Now in the lower classes you have studied already what atom contain. What it will contain atom? This is a atom. This atom contains positively charged proton and neutrally charged neutron. Positively charged proton and the neutrally charged neutron. And negative charge electron will be revolve around in it. We know. We know. Clear? Now here this is cation. How the cation is forming? How the anion is forming? This is a neutral atom. And this is how the cation is forming, how the anion is forming. Now I will explain very clearly. Now listen carefully. See here cation. Here we are going to see with the what? Cation. First I will explain about the atom. Atom contain proton and neutron and the electrons revolve around in it. First of all, I want to talk about the which one. I will talk about the. I will take helium atom, or else we'll take with the. Better we'll go with the some higher one. Beryllium will take. Beryllium normally now we are having 3 atoms. Now we'll move with the ions. What the ions? These are formed by gaining or the loss of the electrons. Now normally if we are talking about the which one? About the atom, we know positively charged protons will be there and neutrally charged neutron will be there and negatively charged electron will be revolved around in it. We know. Here this is about the atom. Here how the atom is neutral. How we can say that atom is neutral? When how many protons? Here if suppose 2 protons are there, same number of electrons it should be there. If suppose we are having the 2 protons here, same 2 electrons it should be there. Now you can see here, best example you can see here. How many protons we are having? How many positively charged protons you are seeing? 4 positively charged protons you are seeing. Same negatively charged electrons are how many? 4. So that's the reason atom is neutral atom. That's the reason we are saying this is a atom is neutral. Now what is the meaning of the cation? What is the meaning of the cation? What we can say when we can say this is a cation and when we can say this anion? Now you can see here how many positively charged protons we are having? 4 positively charged proton we are having. In this positively charged proton, 1 electron is removed, right? 1 electron is removed. due to the removal of, how the cation is forming, removal of electron. Due to the removal of electron, cation is forming. You see, positively charged protons are 4 and electrons are 3. Clear? Removal of electron forming the cation. Now you can see how the anion is forming. Gaining of electrons. Gaining of electrons will give you the anion. You can see here how many protons we are having? 4 protons we are having. How many electrons we are seeing here? 1, 2, 3, 4, 5, right? So gaining of the electrons leads to give the anion. Removal of electron leads to give the cation. Removal of electron leads to give the cation. And number of protons, if it is equal to the number of electrons, that is a neutral atom. That we call it as a neutral atom. Clear? Now, here next we'll move. Next we'll move to the how the cation. What we can say? What is the meaning of the cation and what is the meaning of the anion? You can see best example I will say how the cation is forming. First of all, here I will take well-known example for you how the cation is forming. Mg plus 2 or Mg solid. This is Mg solid. This Mg solid here by the loss of 2 electrons. This is, you can see. Next I will say you one another example, well-known example for you, that is normally we'll go with the one general example. Oxygen will take. Oxygen by taking 2 electrons, it will convert into the O2 minus. Here you can see this magnesium, normally its atomic number we know. This magnesium by the loss of 2 electrons, here it got it as a charge. It is got it as a charge. How much? This plus indicates that, what this plus indicates that? Loss of electron. This plus indicates that loss of electron. How many electron? This plus 2 indicates that loss of electron. How many electron this Mg lost? 2 electrons. Now this oxygen, before it is a neutral. Now here I was added the 2 electrons. I was added the 2 electrons to the oxygen. Now due to that oxygen, it is having the minus 2 charge. This minus indicates that gain of electrons. This gain of electrons. Now in our very important chapter that next we are going to study, that we call it as a redox reaction. In this redox reaction, it will play very crucial role. What is that? Here the magnesium, by the loss of 2 electrons, it got the plus 2 charge. And this process we call it as, what we call this process? We call it as a oxidation. This one we call it as a oxidation. What is the meaning of the oxidation? Loss of electrons. This magnesium has lost the 2 electrons. So magnesium has oxidized. This process we call it as a oxidation. Now you see oxygen, it has gained the 2 electrons. It has gained the 2 electrons. When the oxygen, neutral oxygen atom has gained the 2 electrons. Now this gain of electrons we call it as a reduction. This one we call it as a reduction. Clear? One is oxidation, one is reduction. Is it clear? Now next, and one very important point, many of the students, they will make you mistake here. What? In the chemistry, don't consider plus means addition and this negative means subtraction. Here what does this positive charge indicate? This is a positive charge, indicates that loss of electron, we call it as a cation. This negative charge we call it as gain of electron or anion. Clear? This you have to remember. Clear? Next we are going to move to the periodic table. I hope we are in this periodic table. We are having how many elements total? 118 elements we are having. Detailedly we are going to study about this 118 elements, but while we are starting our chemistry, at least you should need basic elements to remember up to 30. First, basic elements up to 30 elements remembering is a very basic thing. Clear? Here first, this is 1 to 30 elements up to here. Up to here, remembering of the elements, it is a basic thing. Done? I hope you know this, how the periodic table has been divided. We know the periodic table has been divided into 4 blocks. That is, one is S, one is P, one is D, and one is a F. Clear? Done? S block, P block, D block, and a F block. This is a one basic that we know. Already we have studied in our lower classes. But remembering of the 30 elements is a basic priority. Next, we are going to move to the symbol of an element. Symbol of an element. How we represent one element in the chemistry. First, here we are going to take one X. What is this X represents? Symbol of element. This is a symbol of one element. And here we are having the Z, and here we are having the A. Here we are having the A. What this A represents? This is a atomic mass or mass number. What this Z represents? Atomic number. Atomic number. Here this X represents the symbol of elements and Z represents the atomic number. A represents the atomic mass number. Clear? Example for you. I want to show you for you. Normally, if you want to express the hydrogen atom, hydrogen we will represent in this manner. Hydrogen, symbol of the hydrogen atom is H, and its atomic number is 1, and its atomic mass number is 1. Now, if you go it for the sodium, normally sodium atomic number is 11 and its mass number is 23. Done? If you go it for the aluminium, its atomic number is 13 and its mass number is 27. You can see here, you may get a doubt. Sir, here the atomic number is 11 and its mass number is 23. Sir, you have said that in the atom, how many electrons are there? That many protons will be there. How many electrons are there? That many protons are there. But here, if you calculate with the 11 plus 11, it will be the how many? 11 protons and the 11 electrons are there. But what is the change here? We got the atomic mass number 23. How to calculate the atomic mass number? How to calculate the atomic mass number and how to calculate the number of electrons and the number of protons and number of neutrons. Calculation of number of protons, number of electrons and the number of neutrons. This is very, very key basic for our chemistry. If this basic is clear for you, now in our basic level of the chemistry, if it is clear, in the higher level, you may not make any mistakes. First of all, what I said, atomic number Z is equal to number of electrons will be equal to number of protons. Okay? Then, if I want to say atomic number 6, if I say, atomic number 6 will be related to which one? Hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon is a 6. Now, here What does this 6 represent? This is the atomic number of the carbon. Means here atomic number of the carbon 6 if they have given means first thing you get into your mind that it is having the 6 electrons. At the same way it is having the 6 protons. Now listen here. I want to draw for the carbon. Carbon, this is a nucleus. Nucleus we are having the protons and the neutrons. Neutron is a neutral charge. Proton is a positive charge, right? How many protons we are having? 6 protons we are having. Total 6 protons we are having. How many electrons we are having? For the carbon atom, we are having the 6 electrons. This X represents the electrons, don't get confused. Okay. Now, for the one carbon atom, number of electrons will be equal to number of protons. Number of electrons will be equal to number of protons. Now, here, how to calculate the neutrons for this carbon atom? So, I want to represent the carbon atom here. This is C and its atomic number is 6 and its atomic mass number is 12. Now, here we'll calculate for the which one? Carbon, number of neutrons. They will give you in this manner. Carbon, in this manner they will give you. Here, number of protons will be 6. Number of electrons will be 6 and number of neutrons. How to calculate? Number of neutrons, first of all, you see here atom normally proton contain atomic mass is equal to how to calculate this atomic mass? This atomic mass will be calculated on the basis of protons plus neutrons. Protons plus neutrons. We see here protons plus neutrons will give you the atomic mass number. If you calculate it for the which one? Sodium. Sodium we are having 23 atomic mass number and the 11. Here you are going to see which one? What does this 23 represents in the sodium case? In the sodium case this 23 represents, you can see atomic mass number will be equal to number of protons in the sodium is 11 and neutrons will be how many? Neutrons will be 12. Protons are atomic number 11. Then to give the 23, number of neutrons are 12. Here also carbon we are having the 12, right? Means protons are 6, neutrons are also 6. Now how to identify the neutrons? Neutrons will be equal to atomic mass number minus protons. Atomic mass number minus protons. Here the atomic mass number is 12 and protons are 6 and the neutrons will give you 6. Neutrons will give you the 6. Now, if suppose I will give you one question for you. Identify number of protons, neutrons and electrons in molecule if they are given. Molecule if they are given. CH4 they have given and NH3 they have given. Okay. Next we are taking HF. Okay. I will explain it for the one and the remaining you can try it from your own and you can comment over there in the comment section. First, if you want to identify number of protons and the number of electrons and the number of neutrons in the CH4. First what you do? First this carbon, right? And we are having the 4 hydrogens. 4 hydrogens. First of all, find the number of neutrons in the hydrogen. How to express the hydrogen? Hydrogen 1, 1. So how to identify the neutrons? Neutrons will be equal to, how to identify the neutrons? I have given this formula. Neutrons is equal to atomic mass minus protons. So here atomic mass minus protons. Atomic mass is 1 for the hydrogen and the number of protons will be equal to atomic number 1. Neutrons are zero. Neutrons are zero. Remember, hydrogen, it is having the zero neutrons. Hydrogen, it is having how many? Zero neutrons. Clear? Now, I want to calculate total number of protons. Protons in CH4. Here, protons will be equal to the atomic number of the carbon 6 and 4 we are having, right? 4 we are having, right? Hydrogens 4 into its atomic number or protons, atomic number, right? 6 plus 4 will give you how much? 10 protons. And if you want to calculate electrons, electrons for the CH4, electrons will be equal to atomic number 6 plus how many electrons will be there in the hydrogen? 1 electron. 4 into 1, total it will give you the 10 electrons. If you want to calculate for the neutrons for the CH4, here if you want to calculate for the neutrons for the CH4, we are having how many? 6 neutrons for the carbon and 0 neutrons for the hydrogen. Total it will give you 6. Total it will give you 6. Clear? In that manner, same thing you calculate it for the ammonia and same thing you can calculate for the HF and you can comment in the comment box. Okay? Now, by this, I was going to end our class. Clear? And the remaining we are going to see in the next lecture. Okay? Bye.